Hello, my friends. Welcome to another fantastic episode of the AI Show. My name is Seth Juarez, coming to you from my basement. I don't have a basement, I'm just kidding. How is everybody doing today? Hopefully everybody enjoyed I Should Go and Be last week. It was fantastic. Learning all about deep learning and stuff. All right. Let's see what the people are telling me here today. Where is everybody coming from today? I'm going to just look over here. Jose Silva is here. Jose. Hold on. Jose Silva. Bienvenido, amigo. Sometimes I do the show in Spanish, okay? Who else we got over here? Happy Friday to you too, my friend. Welcome. Sharafuddin, my friend. It's good to see you. Good. A question already. Which deep learning model do you recommend to inspect cracks in a plain marble rocks? My recommendation would be to use the one that works. The one that... I don't know. Swati is going to tell us some cool stuff that might just find the answer on your behalf. Hello, Mehdi. It's good to see you. Where's everybody coming from, by the way? AutoML identifying named entities. Oh, maybe. We'll see. I'm not the expert here. Did I see that Cassie was in the ML.NET community? She should be in everything. You know? But yeah, where's everybody coming from? Just put in the chat. I want to make sure everyone feels like they can participate. The only part we do not participate, obviously, in is in the, you know, the part where we're doing like the show, you know, that goes on our website. Desde Ecuador, DF Meta, bienvenido, or bienvenida, I'm not sure. Cool beans, it's time to share my desktop so that we can, let's see, share screen. Yes, share screen. Yes, which screen am I sharing? This one. I made it funny today, everybody. I want you to see it. Everyone's going to yell at me. This morning, my cat, who barfs when he's cold, barfed on my other cat, who likes to eat barf. Sounds like a crypto fintech startup story. Yeah? I thought it was funny. And that's all that matters. All right. We're getting the whiteboard out. And if you're looking at this whiteboard today and you're like, that looks different, it's because it does. I went to start it up this morning and it's like, please log in again. I'm like, what? We have a fantastic show for you today. Ugh, if I could just learn how to use. I pushed the wrong button. By the way, pandemic purchase. I know, it's different, right? Number one, we're doing AutoML for images. Boop, boop. AutoML for images. Number one. Number two, Cassie was like, hey, Seth, can I crash your show? And I was like, sure. Famous last words. Plus some cool stuff. Now, here's the thing. I think it's Onyx related. And the reason why I'm excited for her to come on is because y'all know, if you've been following along when I've been building my project, I've run into some Onyx challenges, shall we say? Challenges. She's going to sort it all out for us by showing us the Onyx goodness. And then Avi, whatever time's left over, we will, of course, work on rock, paper, scissors. Last time, it came down to the wire 2 weeks ago. I was able to get the thing to do inferencing on a squished image. It was probably the greatest moment of my life at that moment in time on Friday, roughly 10 minutes before 1 p.m. greatest 10 minutes of my life that day at that time. It was, I don't know what to say. It was awesome. So we'll continue that. If we have time, we'll see if we can get into the bits and do some cropping of the actual pictures there so that it can work. All right. So that's what we're doing today. That's it. I don't need this anymore. But I wanted my wife to know that I'm actually using the stuff, because I have like a whole shelf of stuff that I purchased that I thought, or I told her, this is important. And she gave me that loving look. You know the one? Are you sure? Oh yeah, I use my Wacom tablet every week for about 30 seconds. So obvi important. All right, let's see where people are coming from here, and then we'll get Swati to show. Fremont, California. Awesome. Oh jeez, I'm like showing you my screen. I don't need to show you this anymore. I'm sorry. There you go. Fremont, land of the Tesla. Wonderful. Onyx runtime related. Indeed. Question: does AutoML for images use under the hood TensorFlow or PyTorch? What a wonderful question. By the way, Swati is going to come on soon, and I asked her if it's okay after we do our official segment, would she stay and answer questions? And she said she would, but only if she liked them. So they better be good questions. Don't embarrass me in front of the product team, okay? I'm just kidding. Just kidding. Y'all are never embarrassing me. Wacom one seems cool. Yeah, they're all cool. And like I said, I use it every other Friday for about 30 seconds. Manchester, England. That's wonderful. You know, if I got to choose another country to live in, it would either be the UK or some wonderful island somewhere. Wait, those are the same things. Oh, here we go. It started. City or United? I don't know. I'm a fan of the Richmond team. If you know it. Richmond, you know, Coach Lasso? Is that not a real team in the UK? Is all of this a lie? Thank you for coming. All right, it's time to bring up Swati. When can I use auto? Oh, the questions are coming. So I'm gonna bring a Swati on here. How you doing, my friend?
Doing good. How are you? Happy Friday, Seth.
Happy Friday to you, my friend. So yeah, I'm excited to talk about AutoML for images with you. Let me bring my doc.
I'm excited too.
What's that? You're excited?
I'm excited too.
I feel bad because like you're probably coming on to the show and like, what is this? I thought this was a professional thing. It's not. It's going to be professional in a second. So basically, for those that don't know, I actually meet with folks beforehand and then we talk about what we're going to talk about. So that way, you know, I'm not going to ask like a crazy question, like what's the secret of life? But obviously, Swati knows that question. She's going to do people's horoscopes after we do the actual part. Yeah. Okay. Cool. That's what I thought. And so what I do is I actually right here I have a doc that shows me all of the goodness of what's going on. Let's get your screen on here so that we can make sure. There we go. There we go. So now everything's good to go. And now I just click button. So I'm gonna kill the background music. Swati, just for you, I'm gonna start out. You're not gonna want to miss this episode of the AI Show where we talk about AutoML for images, building your computer vision models. I'm pretty excited. Make sure you tune in, and then I'm gonna go like this, and then we're gonna talk again, and then we're gonna and then I'll share your screen like this, you know, and it's gonna be wonderful. Also, a couple of tips for you. You know this because we talked about this. If you run out of things to say, just stop talking. I'll ask the next time. And trust me, there are no dumb answers, only dumb questions, and those come from me. And if we mess up, don't say something like, "Hey, can we edit that out?" Because then I'll have to, and you know, I don't want to. All right, now it's serious. It's serious. I think the marketing people are here. They're watching this. I don't want to get fired, on a Friday. Monday, okay. Not a Friday. All right, you ready, Swati?
I am.
All right, let's do this. You're not going to want to miss this episode of the AI show. We're going to talk about... I messed up already. Just a pro tip, Swati, when you're reading things, read the words that are there, not the whatever. And then also make sure you look at this. Make sure you look at the camera, because otherwise people will think you're not looking at me. And we don't want that. All right, you ready?
Yeah.
Okay, here we go. You're not going to want to miss this episode of the AI show where we talk about building computer vision models using AutoML for images. Make sure you tune in. Hello and welcome to this episode of the AI show where we're talking about building computer vision models using AutoML for images. I'm here with Swati. How you doing, my friend?
Doing good. How are you doing, Seth?
Fantastic. Why don't you tell us who you are and what you do?
I'm Swati Gharse. I'm a product manager on the Azure Machine Learning team. And I am very excited to talk to you all about a brand new capability we launched just this past week. This is AutoML for images, where you can use AutoML to build computer vision models.
Fantastic. So let's start with the kinds of problems that computer vision can actually solve so that we can ground the discussion in the actual problem set.
Yep. Yeah, so there's a whole bunch of problems actually out in the industry. So customers across various industries, they're looking to build models that can process image data. And applications can range from image classification of fashion photos, say on the internet, or PPE detection in industrial environments. And this includes a variety of tasks, including image classification, object detection, instance segmentation. And AutoML has newly added support for all of these computer vision related tasks. So out here, I have a quick slide showing, what these tasks mean. Image classification is simply identifying different classes. Like here, you can see, are there cats, are there dogs? And we support both multi-class and multi-label. With object detection, you might want to find out where exactly are these cats and dogs and draw rectangular bounding boxes around them. And with instance segmentation, you want to do this detection at the pixel level and draw polygons around these. And AutoML has added support for all of these tasks where it can boost data scientists' productivity as they're building models for these kind of computer vision tasks.
This is awesome. So for those that don't know, this is actually a challenging problem. Could you tell us why it's challenging?
Absolutely. So in the ideal world, when you're building models for computer vision tasks, you would want to have an easy way to build these models. But at the same time, you also want to have control on how that model is trained so that you can optimize model performance, right? And you want to use these models out in the real world. So you need to operationalize them. And you want to have control on the end-to-end model lifecycle once that model is generated. But in reality, what happens is data scientists are traditionally relying now on really manual methods for manually building these models, right? It's a tedious task trying to try these different algorithms. You come in with your own training scripts. You got to identify the right hyperparameters that are going to make your model work. And all of this typically is painstakingly manual and requires a lot of data scientist effort and time, right? Something that's at a premium. So that's where AutoML can help, because using AutoML, you can easily build models for all of these computer vision related tasks without having to write any training code, right? AutoML makes it really easy for you as a user to optimize your model training so that you have a model that performs really well. Like you can control the model algorithms and the hyperparameters. And once that model is generated, you can easily deploy this model as a web service in Azure Machine Learning, or you can download it and use it in your local inferencing scenarios. And all of this comes to you as a part of the Azure Machine Learning service. So you can very easily and seamlessly integrate with other Azure ML capabilities. And I'm talking about things like the data labeling capability in Azure ML, right? So you can now have multiple labelers coming and labeling your training data. You can export the training data and use that with AutoML, or you can bring in your own labeled data set if you already have labeled training data. The other big thing we hear is about operationalizing these models. Because AutoML is a part of Azure Machine Learning, once you've generated this model, you can very easily operationalize it at scale using the MLOps capabilities within Azure Machine Learning. So think of things like automated retraining or batch scoring. All of this is within your control.
This is awesome, but generally when we talk about AutoML, it feels a little black boxy. And you talked about data scientists. How does AutoML for images go about solving these challenges in a way that empowers data scientists, but also allows them to look inside?
That is a great question, because I think you summarized this really well. This is about letting the data scientists control all of the different things that go into model making and empowering them to be more productive. So as a data scientist, you can come in, and while you're training these models for the different task types, you can select from a variety of state-of-the-art algorithms that we support, right? And here I've named some of the algorithms that you can use. And you can either come in and say, choose this one single algorithm and try that out, or you can choose multiple options and explore these multiple algorithms in a single AutoML run.
Right.
The other big thing that's really important, when data scientists are building models, is finding the right hyperparameters, because your model performance is going to depend heavily on the values that you choose, right? And of course, you got to have your machine learning knowledge and your data science skills, because you got to know what hyperparameters you're tuning. But AutoML exposes a variety of hyperparameters for each of these tasks. Many of these hyperparameters are model agnostic. Some of them are task specific and some of them are model specific. And by exposing these hyperparameters, you as the user can easily try these different values and tune your model for best performance in a single run. So think of things like learning rate or batch size, and all of this you can try very easily, explore it all in a single AutoML run, while you're still leveraging your machine learning skill, but you're being way more productive because all of this is happening so easily in a single run.
Interesting. So this is more like a stick shift car as opposed to an automatic car, because you actually need to know, like, for example, if you don't know what a YOLO V5 is or a faster RCNN or RetinaNet, this is probably not going to be for you. But if you're a data scientist that wants to go through the entire process of figuring out what's the best solution, this is a good shotgun to get a sense for where things are, right?
Yeah, absolutely right. You can, once you know what to try, this allows you to try these different values very easily.
Interesting.
And I like that analogy. I'm going to use that the next time.
Yes, I did a good thing.
It's the stick shift car of model building. I like that.
Okay, cool. So now I feel like I want to see how it actually works. Can you give us a demo of the capabilities?
Absolutely. Let me bring that on here. You have my screen?
I got it.
All right. So here's a sample notebook I'm going to show you guys really quick, where a user is coming in, and let's see what the user is doing. I'm going to build an object detection model here for a simple task of detecting objects from my fridge, right? I have a toy data set with things like cans of Coke or water bottles, and I'm going to use AutoML to help me build an object detection model for this. And to get started, I'm using all of the goodness of Azure Machine Learning. I create my workspace, I bring in my compute target, set up an experiment. Out here, I need to bring in my training data. And like I mentioned earlier, I can either bring in my previously labeled training data, or I can use, I can leverage Azure Machine Learning's data labeling capabilities and export that labeled data to use for training. But let's get to the good stuff real quick. So all of this notebook shows you how to bring in your training data and create that as an Azure Machine Learning data set. But here is the part I want to show you where you can get started with the AutoML goodness. So let's say I'm getting started, and I know I want to try YOLO V5, but to start, I'm not quite sure which hyperparameters to use, right? So I set up my AutoML config like this. I say my task is object detection. I give it my compute target, my training data. I can optionally give it validation data, or it'll reserve a part of my training data set for validation. And here I come in and say, try YOLO V5. In this example, I'm giving it just one algorithm, but I could totally have used more. And by doing this simple step, it's going to try the default YOLO V5 algorithm with default hyperparameters for me, right? But now I want to take this one step further. Like I really want to get the best model performance out of this. The default was good, but I want to see how much more performance and accuracy I can squeeze out of that model. So I can now come in and easily tune the different hyperparameters or try different algorithms all in a single run. And here's how I do that. So in this case, I'm trying a combination of YOLO v5 and faster RCNN. And for each of these, I'm calling out which hyperparameters I want to tune. I'm actually giving it ranges of learning rate, giving it different choices of model size. Similarly, with faster RCNN, I'm using different learning rates and optimizers. And I can build this model space however I please and try multiple algorithms. For each one, I can try multiple hyperparameters. And then here, I control how I'm actually going to be trying all these different algorithm and hyperparameter combinations. So I give it my budget. I leverage concurrency of my compute target. I had a multi-node compute target here. And I can select things like what kind of sampling do I want? Do I want random, or I can pick Bayesian or grid as well. This is another cool feature where I can leverage early termination, meaning any of my configurations that aren't performing as well will be automatically terminated to save me compute resources. And once I've set up my config, I go in and I say again, hey, give me an object detection model. Here's my compute target, my training data, boom, submit this run.
That's cool. Can you scroll up? I have a question here because I want to make sure I'm understanding this correctly. So basically, this parameter space is you saying, if I were to do this on my own as a data scientist, I would go through all of these choices, one by one, but I'm just going to put them in a parameter space and tell AutoML for images, just go do all of that for me.
Absolutely right. And you're right. When you were doing this manually, you would be trying one at a time, going through that manual iterative process. Did this work? Did this not work? What should I try next? Here, you're not only saying try all of these, but if you take a look at the learning rate here, right? I'm simply saying here's a uniformly distributed space. Try values from 0.0001 to 0.01 and pick randomly from that space, right? I'm not even calling out individual learning rates. Like I can basically give it a continuous or discrete space and tell it how you want it to sample from that space. And it does that all for you in one run.
That's really cool. Okay, so what does this look like when it actually runs?
Good question. So out here, I have a completed run with a similar parameter space that I gave for object detection. This is my completed AutoML run. I can go in here and, okay, it's loading.
As it's loading, so basically it's running all of these experiments for you on the cloud compute. Is that right?
That is correct. It's running it's doing your job for you while you go get a coffee.
Yes. So you can.
But you still need your skills.
That's right. So basically, it's like because the cool thing about this is if you're having an image if you have an image, not an image problem, but like an image classification or object detection, you can basically just say over the weekend, all right, let's try all the things that I know kind of work, and then leave it running over the weekend, and then you will see something like this at the end.
One of my users actually said exactly that. They said, this functionality is so cool, I'm getting my weekends back.
Nice.
All right, so anyway, so once I have my models, right, this is my leaderboard of all the top models, and you have complete visibility into what was tried, what hyperparameter values were tried. I can select any one of them and then go either deploy the model out to Azure Machine Learning as a web service, or I can download the model and use it locally. And then I want to show you real quick a couple other things. Here are my child runs. I can go, I can go and explore each of these and see how all of those performed. So out here, you can see these runs that weren't performing as well. They got early terminated, which is super cool for me as a user because it's saving me compute resources, right? These weren't promising runs. What's the point in spending compute resources on that? While these runs up on top are the ones that were doing well, and the system automatically decided they should continue all the way through the end because those are going to give me the most promising model performance. And I can then get into any individual run here. Let's take this guy, for example, and get into the outputs. And out here, I can access the model PyTorch file or the Onyx file, and I'm free to use it however I like in my.
That's the next question I was going to ask, because sometimes when we're looking at auto things, it feels like we get locked in, if you're going to use our auto thing, you're going to have to use our auto, basically when you're running this, the outcome is whatever you would have done before as a data scientist, except it was done automatically for you. Can you do whatever you want with the models?
Absolutely. At this point, you can take your model and go and deploy it as a web service out in Azure Machine Learning. Use that in your inferencing scenario. Or let's say you have a local inferencing scenario. You can download these model files right here and use them in local inferencing. And then you can also use these with other MLOps capabilities within Azure Machine Learning, right? You can now use this for automated retraining, batch scoring, whatever else you would do with a custom trained model in Azure Machine Learning. You can go ahead and do that. You have full control of your model.
It feels like a really awesome productivity tool for someone that wants to solve a computer vision problem. Now I'm going to ask a question that might seem, to me, there's a little bit of a confusion. We have something called custom vision. We have computer vision, custom vision, and now AutoML for images. Can you maybe describe what the difference might be and when you might choose one over the other?
Great question. So custom vision is a great tool that helps you build computer vision models without needing any data science or ML expertise, right? These models are built, they're pre-trained with data sets that are optimized for specific tasks. Sometimes, though, your scenario might require you to have more control on either model training or model deployment or, just the end-to-end ML lifecycle of that model.
I see.
And when you need this additional control, AutoML offers you all of this control and flexibility while still making it easy for you to use. So think of AutoML as being targeted to data scientists with ML expertise in the computer vision area, but it's boosting your productivity as a data scientist as you're building these models.
I see. So AutoML for images is like stick shift. Custom vision is like you driving your own automatic car, and computer vision is like getting chauffeured around, so to speak, because everything is a lot like you basically are doing less and less of the data science work at that point.
I like your analogies. I guess you could say that.
Fantastic. So where can folks go to find out more?
So I'm going to share a link to a release announcement that has all the information on the wonderful capabilities here, and also, more importantly, links to documentation and sample notebooks. I would love for folks to try this out and get feedback on the product.
Fantastic. Well, Swati, thank you so much for being with us. We've been learning all about building computer vision models using AutoML for images on the AI Show. Thank you so much for watching, and hopefully we'll see you next time. Take care. Boom! Look at that. One take. You're a pro. All right, here people are asking questions. There's tons of questions. So let's see what we got. There's 20 questions. Holy cow. Let's go through here. Okay, here we go. People are saying things. When can I use AutoML?
I love that question.
Yes.
So you can use AutoML now. Just this past week, we went public with the release of AutoML for images. Seth, you're going to be including links to the release announcement and the sample notebooks, right?
Like right here. This is the blog that has all the things.
Awesome. So yeah, you can use it right now. Go ahead, go to that blog post. That should have.
Oh no. Is it me or is it her? So I guess the answer, Sharafudin, is now.
Thanks to.
There you are. You're back now. Okay. You broke up for a little bit. So you said something about like go to the blog post, and then you got a little slow after that.
Oh no, I said go to the blog post that has links to documentation.
Cool.
That'll tell you how you can use this, and also sample notebooks that are catered to different task types, so you can get started kind of easily depending on if you want object detection or image classification. But the short answer is now.
Now, love it. Here's Miller. I thought this was a professional thing. It isn't.
It is. What do you mean?
It is. Yeah, it is because she's here. As soon as she goes, all out the window, all of it. All right. Here's another one. But this is an NLP question. This is about images. What steps do I need to use to implement NLP? Local language NLP is fascinating to me. I actually started in NLP. Many people don't know that. I did computational linguistics in my graduate work at the University of Utah. It was great. But I was doing IBM models 1 through 5. That's how old I am. And she's laughing. She's like, oh, yeah. That was in my textbook too, from 50 years ago. No, I was doing noisy channel models because at the time, neural networks were not popular again yet. if you're a data person, if you're a machine learner, you know what I mean. Deep learning wasn't popular again yet. So there's that. Here's another one. Can we edit that? Let's see. Other questions for computer. Oh, adaptive vision. Okay. I'll tell you that this thing is actually really cool because the models that I saw y'all using, Swati, are state of the art. Like last time I did a YOLO thing, it was YOLO V3, and I didn't know there was a YOLO V5. Good for y'all. Oh, look at this. I've got 12 years of my family photos. I would like to classify my photos, my kids, my wife, and separate my friends and put it. How can I do this with AutoML? Well, you'll have to label all of them first.
Or I was just thinking, you're going to need a lot of labeling, training data here.
But there's an auto labeling feature but it builds a model too. So yeah, there is that.
But the auto labeling thing is actually cool. I'm glad you talked about that, because if you go to Azure Machine Learning's data labeling tool, as you're labeling your data, when the system realizes that it has sufficient training data, it assists you using a model behind the scenes, but it assists you in going and completing your labeling task.
Oh, it's like we're using machine learning to help you label something to do machine learning.
That's right. So meta.
Inception machine learning. Here's a question. Can instance segmentation extract circles? I'm tired of finding hyperparameters for different algorithms.
Instance segmentation extract circles. You mean like polygons? Yeah.
I think they mean polygons, but more like the thing. Here's the secret. Like I told people at the University of Utah, it's super famous for coming up with like graphics, like Phong shading and all that other stuff. Actually, the guy that made Pixar did all his research at the U. And it turns out that there is no such thing as circles in computers, only sufficiently small triangles. So it just depends on the segmentation, right? If you want to.
Yeah, I mean, you could, if you had circular objects, then it would find polygons that look like circles, I guess.
Yeah, there you go. Here's another one from Tyndall. This kind of stuff is so much more impressive than normal. Yes, the amount of math going into this. I'll use I'm going to say it in a good voice. Multivariable differential calculus is what is needed. My favorite math, by the way, of all the math, calculus is the best. But this is the question from Tyndall. Is it possible to download and run the model locally once it's trained, or do you need an active connection to Azure during runtime?
You can do what you need with that model. If you recall, I showed how you can select that model and either go deploy it to Azure, like as an Azure Machine Learning web service, or you can download the model and use it locally if your scenario needs you to be, local, disconnected from the interwebs.
That's cool. And that's the part that I wanted to get to during the show that was actually really quite good. Here's a cool thing. And because it's the answer you're going to get, Jose, is not what you think. Does it require AVX instruction set? The thing is that I don't care as a data scientist if it does. I'm like a fake data scientist. I'm more like an ML engineer. But it doesn't. This kind of stuff is abstracted away, right, Swati?
It's totally abstracted away. You are coming in and seeing exactly the interface I showed you on the Python SDK, where you're saying, I want YOLO V5 or faster RCNN. And you're giving it GPU compute to run, to train your model. Everything else is abstracted out.
Cool. Here's a question from LinkedIn. Is this a Teams meeting? We can make it one if you want, Ted. If we want, because I know like you're coming in from LinkedIn and it's like, this needs to be more professional, like a Teams meeting. There are questions on LinkedIn. If you ask questions from LinkedIn, I'm simulcasting this to Twitch and YouTube and LinkedIn. Is it used in CCTV devices for everyone? No, I mean, this is a good question. We're in the business of helping you make models. What you do with them, we hope people are ethical with them. We have a series of 6 ethical principles at Microsoft. I'm not kidding. Look up ethical AI at Microsoft, and you'll see responsible AI, and you'll see we have 6 very specific principles that one day I will memorize and recite to you. Oh, look at this. Can we use AutoML like autopilot for a car? Oh, that's an interesting question.
I think he means, or she, sorry. I think the question is more about, can you go more auto? Mm-hmm. And the answer is like the very first example I showed. You could simply say, give me a YOLO V5 model, because you heard YOLO v5 was cool, and it'll find you the default, like it'll train a model using the YOLO v5 algorithm with default hyperparameter values. You don't need to go any more stick shift than that if you don't want to. But the USP here is that you can go stick shift when you want to, right? That you can squeeze out the maximum performance.
And if you're trying to make a self-driving car, you can indeed use this to create some of the models that you may use. But I like self-driving cars. Someone was asking. I'll turn the music back on since we're all like in fun mode now. Someone asked me about self-driving cars. Do you trust them? And I'm like, yes, but only on the freeway. And everyone's like, wait, that doesn't make any sense. And it does, because on the freeway, the picture is the same, right? And so the computer can learn that a lot easier, in my opinion. I think Swati is frozen. She's not. Is AutoML only for images, Swati?
Nope. AutoML actually has had capabilities for tasks like classification, regression, forecasting on tabular data. And the new piece we launched this week on top of that is support for computer vision tasks where you bring in image data. But you can also go ahead and do whatever you want with tabular data.
I've heard that the AutoML system has a recommendation engine running in the back to recommend new machine learning algorithms based on the data. And this is the old school AutoML, but I may be reaching. This was like a couple of years ago when I learned about this research, which is kind of cool. Should look at it. All right, here's a question from Mega Squiggler. Just finished a project that identified pages in scan microfiche where OCR won't work using Loeb and C#. This got me interested in ML for scan page image, saved hours of that's cool. You did a thing. I think that's everything. Swati, anything else you want to add before we're done?
I think this is a great capability. I'm really, really excited to launch this. Like I said, the main thing is it's making it so easy for you to use, but at the same time, giving you all the flexibility and control you need to boost your productivity. So I can't wait for you guys to try it out and send us feedback.
Yes, and Janny Skew number 7. Hold on, I got it. Janny Skew number 7. Thank you. Says AutoML for images looks so great. It is great.
It is.
And the thing that, like, I've heard data scientists say this before. Hey, I'm worried about this AutoML stuff. Is it going to take away my job? No, it's going to make it so you do the fun parts of your job. Data cleaning. I'm just kidding. I didn't mean that. Sorry. Labeling your images. Oh, sorry. I didn't mean that either. Swati had a sad face. All right. You're the best. Thanks so much. We'll talk to you soon, okay?
Talk to you later. Bye.
Bye. All right. She's pretty cool, huh? I work with cool people. I'm just saying. Yeah, if you're, I'm a computer vision guy. Like, that's the stuff I started. The first thing I did was I did computational linguistics, old school NLP. That was my thing. And then I came to Microsoft and I did computer vision because I found that it demos better for an international audience, right? Because a picture of a dog is a picture of a dog in any place, right? Or a picture of a cat, and like chicken tastes the same everywhere. Actually, everything tastes like chicken everywhere. Because it's I'm just kidding. I don't know. And so I decided to switch over to computer vision, and I did a YOLO v3 implementation in Azure Machine Learning for some talks that we were doing. Cassie did those too. Hold on, let me bring her on. Do you? I'm adding you, Cassie. You remember doing these talks, right?
Which talks?
Remember when we did the Ignite tour?
Yes. Mm-hmm.
And we did talks on YOLO v3.
I think I did time series regression.
Oh, see, I did the one. Okay, mine was the last talk then. Yours was like the second one, or I don't know. Cassie, how you doing, my friend?
I'm doing good. How about you?
So you messaged me the other day, and we're like, "Hey, can I take over your AI show?" And I was like, "Less work."
Basically, what I should have said is that I wanted to captain the starship this week.
Hey, between us girls, I've been watching Star Trek Voyager.
Yeah.
It's okay. It's okay.
What about Discovery?
Which one's Discovery? Like, there's so many now.
That's the new one.
The new one.
Yeah, like on CBS All Access.
Okay. By the way, this is not a commercial for Star Trek at all. Maybe it is. I don't know. All right, let's see what people are telling.
So,
by the way, Cassie, So let me finish telling everybody. Cassie was like, "Hey, can I come on and talk about Onyx?" I'm like, "Yes." I've been using Onyx because you've recently moved to the product group, right? You work in the product group.
That's right. Yeah. So I moved from the developer advocacy team to working on the Onyx runtime as a senior program manager. So still doing a lot of community stuff, but it's been really great because now I get to focus on this awesome product and bring some good content there and talk to the community about it. Oh my gosh, can you hear my dog? Sorry.
I thought you were just hungry.
It's my stomach. Shh, we'll eat later.
That's what mine sounds like. Oh my gosh. I don't know what I did today. Today's like a Friday's extra Friday for me or something. Okay. But yeah, you said, can I come on and talk about Onyx? I'm like, yes.
Exactly.
Number 7 is saying dog is hungry for Onyx runtime. I think we all are.
We are. Yeah.
We all are.
So it's really cool because it's an open source project. And we're going to be talking about Hacktoberfest. And this is the first year they've been a part of Hacktoberfest. And so we'll talk about what that is and how you can contribute. And then the other cool thing that we're going to talk about today is like how you can actually start contributing and get into the code base. Because I think like one of the things when you want to start working with a project or a product or an open source thing is you get in there and you have to kind of start figuring out where everything is and how it was built. And you kind of have to like reverse engineer things before you can get in and actually build into it. Right.
Right.
So my thought was, let's see if I could get some of the brilliant engineers to come show us some of that.
Oh, so smart people.
Yes.
Everyone's like, this is a change from the show. From regular programming where I'm sitting there fumbling. By the way, I've been using the Onyx runtime, particularly in using Node. Mm-hmm. And I finally got it to work. I don't know if I was doing something. Maybe I was holding it wrong. By the way, hopefully this isn't a omen for what's to come. Looks like Titanic. The ship is going down. The ship is going. There we go. Here we go. Oh my God. Jose Silva has a very strong opinion of Star Wars versus Star Trek.
They're both great. Why can't we all just get along? And,
yeah.
I think there's positive and negatives to all. There's been so many different iterations of Star Trek too. Like Star Wars, I feel like actually there's been a lot of different worlds put in there too. Like that one, I feel like they're kind of on the same storyline where like Star Trek episodes, they kind of all can sit on their own, particularly yes. TNG. I love TNG. The next
yes, I do too. That's probably one of the better ones. I tried watching Deep Space Nine, but I got claustrophobic. Like they're in the same place all the time. I don't know if I like that.
I haven't watched that one or Voyager, and I've kind of like started both, and I didn't get as into them. But I really like Discovery and TNG. Those are my
Here's Enza API King. I'm so glad I got this channel and recommendation. We can mess that up still. There's still time. Netron is indeed awesome. The dude friended me on LinkedIn. Wait, is it called friended on LinkedIn? Do you friend people on LinkedIn? Is that what it's called?
No. I think you connect. You connect with them because we're professional, and so you connect.
He connected with me on LinkedIn. I'm like, oh my gosh, I'm such a fan. And he's like, because he did two things. He did Netron, and then there was the other thing he did. What was it?
Oh, wow.
Oh shoot, what was it? I'm gonna look this up here.
Who did?
Yeah, there was two things he did. One was for .NET. I'm looking it up right now. Here we go. Oh, somebody wants me to connect for a discussion. Where is he? Lutz Roeder. Here it is. I'm like, oh my goodness, I'm a huge fan. When he friended me on LinkedIn, I'm gonna say friended because I don't care. And he smiled. He's like, Reflector or Netron? Because he made Reflector too. Okay. He was watching I did a competitive analysis on something, and he watched it. I was like, oh my gosh, I'm so embarrassed. By the way, you are now the Onyx RT captain. Apparently. And Mega Squiggler's right. The latest Star Trek, Kirk goes to space at 90, actual space. And I'm going to say something so controversial because you're not till the top of the hour, so we can totally mess it. Like, he got off the spaceship, and obviously he was moved. And he's like, I've had experience in space before. Like, wait, what?
I didn't see this. Fill me in. What are you talking about?
Basically,
and he saw that he was going to space.
He got on a rocket and shot up into space, and then he floated around for a second. They came back down. And it was quite the spirit. I bet it would be like quite the spiritual experience for anybody to go into space.
Mm-hmm.
So maybe one day, when when you're filthy rich, you can invite me to your space flight, and we can all go and we can have a teary moment together of like wonder and awe at this blue globe we all sit upon. And he said stuff like that, like, it's so fragile. Yeah, hold on. He said stuff like, hold on. It was so beautiful. Thank you for giving me this chance to fly. Like it was basically that for like half hour, and I stopped watching it because I was supposed to be working.
So I think it's really cool, but like, what's the environmental impact of like random space travel? Like for no real good reason other than it would be really neat. Like put on a VR headset. I don't know. Like there's I feel like there's better ways. Try one of those like things where they have the air tube and you get to like fly. Although that's more like jumping out of a plane. What's that called?
Skydiving.
Skydiving. Those are more skydiving, I guess. But yeah, I just feel like there's more like environmentally friendly ways.
I know. And then like all these tech giants are like, the next frontier is cleaning up space. I'm like, hey, we have a lot of space down here with bottles in the ocean. Let's clean that up. Oh my gosh. Oh, indoor skydiving. Shirley Dev. He has done that. So much fun. Expensive though. I feel like we went through his whole thought process there. That was awesome. All right, Cassie. So basically, you're in charge now. What do you want me to do? How should we do this? I think Sherlock's not ready yet, though.
Well, I can just start out kind of introducing the content and what we're going to be talking about, and kind of go through our agenda and introduce our engineers. Are they?
Yeah, they're all here. They're all here.
Okay,
so
cool.
I'm just gonna remove myself, and then when you want me to come back, or if I'm not producing this right, you're like, hey, Mr. Producer, can you please? Yeah, she is now the captain.
I am now the captain.
Officially the captain. There is no escaping it. All right, to you, my friend.
He's never going to let me back on his show, is he? Okay. So welcome. I am Cassie Brevu, or Captain Brevu, if you want. We are going to talk about how you can contribute to Onyx Runtime for Hacktoberfest today. And with me, let me introduce, we have Sherlock and Cheng Ming, who are two of the engineers on the Onyx Runtime team who are going to give us some technical deep dives and introductions to how Onyx Runtime works, and then also help us with some ideas that you might want to use to get started. And so the really cool thing about Hacktoberfest is it's very beginner friendly. So there's all types of ways you can contribute. And so if you're a first time open source contributor, like jump in, whether you want to do docs, and we're going to talk about all that kind of stuff. So yeah, it's really exciting. So here's what we're going to talk about. We're going to talk about Hacktoberfest, a little bit more, Onyx Runtime, and then we're going to go over the code and some ideas like I just talked about. So you should follow Onyx Runtime on Twitter if you haven't, and let us know if you decide to contribute and tweet out what you're doing. No matter how small or big, we want to hear about it and hear from you. So if you haven't heard of Hacktoberfest, it is a month-long open source contribution or celebration in the month of October. So we're about halfway through it now, but I mean, it's never too late to start. You can go to Hacktoberfest. I think it's .com. I don't know the exact link, but if you Google it, it'll come up. And join, and that's all you have to do. And then if you go to the GitHub, and you can search for different topics, and if you search Hacktoberfest topic, you can see all the different projects that are part of it. So it is to promote people to get into contributing to open source as well. So like I said, it's very beginner friendly. With Onyx Runtime, it can get really complex. So we're going to kind of go in that way. So if you want to get more into more of a complex PR, you could do that, or pull request. And if you want to just help out with docs or fix typos, whatever your comfort level and whatever you want to do, it is totally welcome. And we're excited to have you. So if you're not familiar with Onyx Runtime, but it sounds like Seth has been using it, so you probably are, but just to kind of level set and make sure everybody knows what we're going to be talking about or what it is. So Onyx is an open format. So when you build a machine learning model and you export it, it'd be an Onyx format, or .onyx is one of the ways. And then once you have an Onyx model, you can use Onyx Runtime. And what Onyx Runtime allows you to do is it speeds up, so it has better performance for inferencing, but it also allows you to do things like cross-platform deployment and inference in multiple languages, meaning I could build a model in Python and I can do my inferencing in C# with Onyx Runtime. But it's not only supported with Onyx Runtime, with C#. If we take a look at the different platforms, APIs, architectures, and hardware acceleration execution providers that are available within it, you can really, it's super powerful. So there is also some features within it to optimize training. So to speed up training. So you're getting the most kind of for your buck when you're using GPUs. So you can use ORT module for training or ORT runtime or Onyx runtime for inference. So when you're converting to an Onyx model, with whatever framework you're using, there are packages to convert. So if you take a look here, you can see if you're using Keras and you have your H5 model, there's a Keras to Onyx package so that you can convert to Onyx, and then now you have that model in Onyx format, and you can get all the benefits of using that. And same with PyTorch, TensorFlow. And then also with PyTorch, the Onyx format is built right in. So you can just do torch.onyx.export. When you build your model, you don't even have to export it to another format. So super convenient with PyTorch also. And then when it comes to inferencing, this is an example for both C# and Python. And here you can see that you just import the Onyx runtime package. I create a session, and then I call session.run. It's very similar between the different languages, right? Loading my model and then sending in my data, and I get back my results or my inference. So within are also the Onyx GitHub, we have a model zoo, which is just a bunch of pre-built models that you can use and just grab and start inferencing without having to build your own. So I'm going to show you just a quick demo of the fast RCNN, which is a object segmentation one that we have deployed on a Xamarin example. So let me show you that quick. And just so you can kind of get an idea how it works. And then from there, then we'll jump into the code. So I have a Android simulator up here. I'm going to hit run on this. So it's going to build my Xamarin application and deploy it to this. And while that spins up here, I'm just going to zoom in on the code and show you how we're actually using Onyx. So this image has already, when it gets to this point, the image will have already been pre-processed to a tensor, and we're going to be creating this named Onyx value for our inputs. And we're going to have a list of inputs. We're going to have multiple objects in this picture that we want to have inferencing happen on. And then from there, we are going to create our session, right? Just like you saw in the slide. And then there's also graph optimization levels. So I can choose the level of optimization that I want Onyx to do. We're enabling all. And if you go into the docs, you can see all the different levels and what they do and how they work. This is specific to Android platform. So I'm just going to kind of ignore that for now and stick to the Onyx runtime stuff. And here, once we create an inference session, so we're grabbing our model. So this is the path to our model. We're creating a session, and then we're just simply calling session.run and getting our results. So this is how you would use it in Xamarin. And Xamarin support is coming at the end of this year. So I'm using dev packages to show you this one. It is supported already if you're just doing iOS or just doing Android, but for Xamarin support, that is what we are looking at here. Okay, so this is kind of just a simple app, a simple sample app to show you how it works. And it's a little bit slow because I'm using the Android emulator, and the emulator is slower than if I was just running this on hardware. The other cool thing is it's doing on-device inferencing, right? So that's a super powerful thing where you can inference both on device, or you can set it up in a service, or however you want to do it. Oh no. Well, let's see here. So it wasn't working, and I got it working, and now it might not be working again. Wonder if I need to rebuild. There, oh, it came back. Sweet. Just needed a second try. Sometimes we need that, you know. So you can see the result here. This is a sample image, and Onyx was able to let us know that there is a dog, although that looks kind of like a cat to me now that I look closely. I don't know about you. There's a bird, a person, looks like a boat here, some more people. So there you go. That is Onyx runtime working on mobile. So I will hand it over to Sherlock now. You want to come on in? Hey,
hello guys.
how's it going?
Hi, good.
Thanks so much for joining and teaching us about Onyx runtime today. I'm super excited to learn more.
Yeah, I'm also excited. So I'm going to just give a little bit like technical detail of how Onyx runtime work under the hood, and give you a little bit of overview of our code base, what are the things that you can learn about by navigating, in the Onyx code base. And in the end, like we're gonna just walk through the code base a little bit and I'll show you around. Okay, so shall I start by sharing my screen?
Yes, and then Sherlock, when questions come in, I might just be like, hey, we have a question I want to ask you, and kind of interrupt a little bit if that's okay. And then I did see one question in the chat. We were using Skia Sharp, SKIA Sharp, which is a native Xamarin package for processing images, as you were asking about that. And I think that's the only question we had so far. Cool. So.
Okay. So can you all see my screen?
Yep. Looks good.
Okay, so before we talk about Onyx runtime, we still have to talk a little bit about the Onyx. So as you know, like Onyx is intermediate representation for like general machine learning models. And for the models that we usually talk about it as a DAG, which is a directly acyclic graph. So as you see here, this is like example of, this is probably image model with convolutions and a whole bunch of value in it. And in the Onyx format, this is how it's going to be represented with different layers. So there's a high-level model, which you can fill it with a whole bunch of metadata, and then at the end of the day, it's a graph, right? For graph, you have input, output. Input, you fit in your data. Output, you get your prediction. And then inside the graph, there's a whole bunch of computation nodes, commonly known as, the actual computation, each layer that you do. And as for each computation node, you also have like certain input and output, and it also tell you like what kind of computation it does. And there's a whole bunch of attributes to it. So at the end of the day, the purpose of Onyx runtime is to execute such a computation graph very efficiently on various kind of device in various kind of environment. And we will do all kinds of graph optimization, kernel optimization, so that it runs really fast. Okay, so that's the purpose of Onyx runtime. So this is like a high-level architecture of how things work under the hood. So as I have just told you, like when everything starts with the Onyx model, you either get it from a converter or you load it from the disk. Okay, but this is some model comes in, and then you have your data, image data comes in, and then finally you have your prediction data comes out. So this is like kind of like the workflow that Onyx runtime on the hood would operate. So first, it will load the model and convert it as in-memory like graph representations. And then we're going to go through a bunch of graph so-called model optimizations, such as like common expression elimination, node fusions, constant folding, etc. So it just makes the model a little bit easier to run and a bit more efficient to run. And if there's some duplicated computation, we're only going to do it once. So this is the stage where models, we basically have multiple passes in the graph to make the model easier to run. And then it is passed into the the so-called model partitioning, because under the hood there could be multiple hardware devices that you can use. Like for example, commonly you have some CPU, you have some GPU, you might have some fancy like ngraph or TensorRT device. So in this case, like Onyx runtime would partition the entire graph and delegate certain part of computation to different devices so that they are run in the most efficient manner. So there's a whole bunch of like partition logic to pick which subgraph to hand it to which device. Okay, and then there's another run of model optimization based on each kind of hardware. Here we call it execution provider. Okay, but it's just like hardware-based optimization. Okay, finally, this like per hardware graph would be handled by this executor. So this executor, you can think of it as a graph, execution engine, which you basically go through the graph one node after another and execute it node after node. So this is the executor, and all under the hood, like as I have told you, there's multiple multiple hardware that you can pick from. This is what we call the execution providers. There's CPU, CUDA, all kinds of device. So this is like the very, very high level architecture of, how Onyx runtime works. Okay, feel free to post any question and ask for more details. So as for the Hacktoberfest, Onyx runtime has a few extensibility points where you can contribute. So I'm just calling out, what are the points that you can contribute to the Onyx runtime. So for example, you can, bring your own hardware and plug it into the Onyx runtime, and you can provide your own kernels and make the model run faster. So like here's some example, like for example, we work with NVIDIA folks, Intel folks to have an execution provider for TensorRT, OpenVINO, ngraph, and of course, like Cassie has just shown you, like what it takes to run on an Android device, right? This is all achieved through plugging in different execution provider. Okay, like once you have the execution provider, you also need to provide its own kernel for that runs on that execution provider. And sometimes you want to bring up your own operator. Like in certain devices, it's just easier to run some operator as one thing. For example, like in the recent NLP endeavor, like the common thing is you run the whole entire transformer layer in one in the device as a one custom app. So in this case, like Onyx runtime also allows you to plug in and bring your own custom operator. Okay, so it doesn't have to be a standard Onyx operator as defined. There's like 200 operators in Onyx, but you can also come up with your own and define schema, define kernel for that. And finally, there's a whole bunch of you can also bring up your own graph optimizers. This is just the different paths to optimize the graph. And in Onyx runtime, this is implemented as through a common interface called Graph Transformer. And we'll show some code later. Okay, so this is all very high level. There's a whole bunch of very technical details that I won't dive too much into in this AI show. But there are two sources that I want to point to you. One is the mind map. I'm going to show you later, and the other is the wiki page. So let me just switch to this to view. Okay, so this mind map is basically a breakdown of all the components. This is in Onyx runtime backend. So as you can see, here we have some user interface which you can explore. We have Python, C#, C++, C, all kinds of user interface. And here you have like more components related to graph. You can write about graph transformer, basic building blocks. Sometimes also support training, how the training graph is built. There's a gradient graph builder that construct the training graph for you. So there's just a huge amount of space for you to explore, and you can dive all into these details. So this mind map will help you navigate in this complex space. And also there's ops and kernels, and there's more advanced topics like execution provider, CUDA programming, at the end of the day, like execution engine, how it works, and our memory manager, all these details. So this is all like open sourced and can be found in our GitHub Wikipedia, like the page. And finally, I just want to show you, like this is our internal kind of view of how a developer, or if you come up into this hackathon project, like how you want to pick your own ideas and expand your understanding of Onyx runtime. So this is kind of designed as a university curriculum. You go through different years and learn different topics. Okay, so feel free to leverage this as use it as a map.
So this is really helpful. Like, so if I'm just getting started with Onyx runtime and I want to learn a little bit more, but I'm scared to kind of jump into the deep graph optimization because maybe I'm not ready for that. The inference session in the ORT module, like that would be perhaps like my C# library that I could go in and download and then start playing with how it works and contributing to it. So that's kind of what you're saying is like the levels, like first step of contributing to Onyx would be working with some of those different language specific inference session packages, right?
Yeah. So you can depends on your own technical level, you can pick on which are the components that you're interested in and feel free to contribute on that particular component.
Yeah, and another like really, I think level 02 is even contributing to our documentation and writing a sample with one of the inference sessions. Like even above contributing to that, documentation contributions are amazing open source contributions as well. So looking at there and seeing if there's something that you built that you're like, this might be a cool tutorial and doing a PR around that as well. So I think those are probably like the first kind of 2 steps you could do if you feel like you're kind of more beginner or new to this. And then if you want to jump into some of the more deep stuff, that's when you can go into like the execution providers or extending it in different ways to improve the product. So.
Yeah, exactly. So like this learning roadmap is actually not specific to Onyx runtime per se. Like this is actually, generally applicable for AI engineers. And this framework, this common concept of graph nodes, kernel, op, all this is commonly applied in all kinds of AI framework like TensorFlow or PyTorch. So this is just like a general roadmap as an AI engineer. How if you are interested in this space and relatively new, like here's the process you can take and topics you can explore. Yeah.
That's awesome. So even if it's like I'm maybe not ready to contribute to the core, but I want to learn more about using this and learn more about how they're set up, this is a roadmap for that too. I love that.
Exactly.
Super useful.
Yep.
Someone commented that they love this ORT mind map too, which I think is super useful. Like to be able to jump in and see, okay, these are the different sections that I could go in and which one of these are interesting to me. So this is great resources.
Yep. Great to hear that. Yeah, so this mind map can be found in the wiki page of the Onyx runtime. So it's right over here. So as you can see, like we're also trying to document some internals of the Onyx runtime, and they are like classified by different topics. You can dive into different articles to learn more about the internals and details of Onyx runtime. So this is all public. All right. So finally, I just want to walk you through the code base a little bit without boring you guys. So this is the main page of Onyx runtime. Okay. As you can see, like this is like, yeah. So somewhere we need to start. So there's only like 2 folders that maybe interest you. One is the Onyx runtime. One is the ORT training. Most of the inference-related code lives under the Onyx runtime, and this is probably the place to start looking at. And this is more like the general framework, the core of the Onyx runtime. As for more advanced topics, like for training-specific ones, you can dive into the ORT training folders. So let's dive into this. Under the Onyx runtime folder, this is pretty standard. You have some Python, which is our PyBind interface that provides the Python packaging, and this is somewhere you can look at how the PyBind interface of the Python frontend is implemented. And then probably the more interesting one is the core. So under the core, you have all the things that I've mentioned: the graph, the optimizer, the framework, the execution engine. And then another thing to call out is this country ops. This is another thing that I just mentioned. Like if you come up with your own kind of optimizer, schema operator, it's all live under this country op. Okay, so under the core, there are a few things that it's a good starting place to poke around. One thing is the session, as Cass mentioned, like the concept of the inference session is the core to every framework. TensorFlow is also called have a concept of session. PyTorch is just a little bit different, but it's a module that you start with eager mode 1. So anyway, like this inference session is the main place for you to good place to start exploring. And another thing maybe I should call out is there's a graph. Graph is abstract representation for this Onyx graph converted into the in-memory graph, and so you can see that there's a whole bunch of common graph components in this space. You have graph, you have node, you have op, you have edges. It's all living under this. And last but not least is probably the more advanced part is about the framework. So inside the framework, you have some memory allocator stuff. You have some data transfer between different devices. So this is getting a little bit deep. And then execution provider, execution frame, it's all under this framework folders. So and kernels, etc. So I shouldn't dive into too much into details. And last but not least, I should probably also just call out to the provider. So as you can see, like Onyx Runtime has partnered with different hardware partners, and we have, you see, I don't know, 10 plus different hardware supported under Onyx Runtime, and they are all pluggable into ORT. So this is another point where if you have your fancy AI hardware, come talk to us. We will be happy to help you, integrate your own hardware into the Onyx Runtime repo, and then you'll be able to execute the Onyx graph with your own Shiny hardware. Okay, so with all that, I think that's all I have.
Can you go to the documentation quick, to onyxruntime.ai and to the docs, because I think isn't there some information there on how to build for different execution providers, and also I thought there was some stuff there on extending it. And then the other thing is they recently deployed the C API. So that might be documentation. Yep. So if you go to the docs part at the top here, and then if you go to the API docs on the far left, yeah, that one too. And then the C++ API docs, I think, is the one that so this would also be really helpful when you're jumping into those different code, when the code base and you're if you're going into the C side, this is a good place to go to understand more about what's happening in the code. So, and then the other thing, I think there was an execution provider piece in the docs as well. Isn't there how to build a custom one in there?
Yes, there's examples for different hardwares.
For each one's, for different execution providers that you might want to use or build for. And the other thing is there could be issues with the existing ones, right? You could go into the GitHub issues themselves and maybe find something that has that maybe execution providers are something that's really interesting to you, and maybe you're kind of new to programming for them. So you could go here and kind of learn how to build it. And then you could go into the issues and see maybe rather than adding a new one, there's something that you could fix with an existing one. And I don't know any issues off the top of my head, but I'm just saying those are another way to kind of do that. Pick a topic that you think sounds really interesting to you and that you want to learn more on. And then from there, from his mind map and all those different topics, from there, you could even, rather than, creating a new feature, look at something small that you could change within an existing feature I think that's another kind of good way to get started within this. And like, I always think when you, and I'm curious how you feel about this as well, Sherlock, but like when I want to learn something new, I think trying to fix something in an existing code base is like one of the best ways to get comfortable in it, because you have to download it. You have to figure out how to run it. You have to find where that exists. You have to recreate the issue. And then from there, like now you're already in it, right? And so I think like those are, for those kind of people that are newer to contributing to this type of project, I think those are like really good places to start. And then if you're someone that's like really advanced and you're ready to like jump in and do add a new execution provider, that's amazing too. But I think because Hacktoberfest is like, there's such a wide array of people that can be contributing, to think about kind of like the novice, like the very new person, and then like the, well, I think I might be comfortable like downloading it and figuring out an issue or a feature that I want, or a new operator or something like that that doesn't exist. And then going into, okay, now how do I actually do this? And then submitting the PR. So this, I hope wasn't like there's a lot of complex things there. And I know like don't get overwhelmed by that, because like with anything, you kind of start small and you take a little piece and then you build on that knowledge.
Yep, totally. Like this whole mind map was actually like, one folks told me like, this is actually a great like just curriculum for AI engineer to, pick. There's just a wide range of AI topics in the AI framework. So, so you can go through each topics to expand your expertise and grow your knowledge and become the domain expert. And then once you're familiar with certain topics, you can move on to the next one. And this way you be like start small and expanding your knowledge and comfort zone, and then finally you have a full grasp of the AI framework.
Totally. I also love too, because just like seeing the level of like complexity and like what Onyx Runtime is doing for you is really cool to see the multiple levels of optimization and what you've thought through in order to make things faster. So it's really cool just to even start to understand the levels when you're using Onyx Runtime, even if you have no interest in like ever contributing to it, which is totally cool too. Like if you just use it, like now understanding better how it's put together makes it easy to use. And then also is like, look at, whenever I use things like this, I'm like, thank you, awesome engineers that did like complicated things for me. So like all I have to do is .inference session. Like, thanks for making my life easier. Like. So I don't know if we see any, I don't have any other questions from the audience yet, or the attendees or the chat. I don't know the correct, there's like many different ways to kind of like call out the chat. And it's like some platforms, they're like the chat, and then others call it, I don't know. Anyways, we'll call it chat. Let's do that. Okay, so here's one. How do you read the bounding boxes of an inference in ORT in other libraries is so complicated? So that actually wouldn't be in, well, I'll let you answer that, but I think that would actually be after processing, wouldn't it? Because it comes back with an inference result and it gives back, I think, the coordinates, right? And then you just draw them. Well, I'll let you answer.
Oh.
Or do you not know?
Okay, so I let me pretend I know what this is asking for, like this. So at the end of prediction, it gives you an output of the bounding box, and then usually it's like 2 points. One is left upper corner, the other is the right bottom corner. That defines the bounding box for you, right? So basically, those are just pixel index. Is that what you're asking for? So basically, like, yeah, it's just a standardized way to read those bounding box, but Onyx Runtime is there to produce those bounding box, but it's up to user to interpret that. Yeah, not sure if I answered the question.
Okay, so the result has the bounding box in for the top corner and the bottom corner, and then from there it's up to the user to take those coordinates and actually draw it. Is kind of what you're saying, right?
Yeah.
Yeah. And I actually have, I think, so, well, I'll see if there's any other questions. I might be able to show some of the code for that in the Xamarin project, but let me take a look. Do you have any other any other things you want to show about the code base or any of the different packages?
Yeah, another thing I think would be interesting to show is the Neutron 2 that I think one of the comments mentioned before. So I'm showing my screen, and just to give you a sense of what it looks like. So can we switch back to the screen? Yep. So you see, this is a model, .onyx model, but it's just a training model. It applies the same to the inference model. So overall, you can see like this is like how you can visualize the whole graph. You have each node and they're interconnected. You can zoom in and then study, the characteristic of each node. For example, this is a map mile and text to input. What's the name of input? You can also search for different kinds of apps, like, I don't know, I want to look for certain map mile nodes, transpose node. This is just a really powerful way for you to visualize and navigate for Onyx model. So just want to call this out. This will come really handy when you are contributing or working on some Onyx models.
Okay, I'm going to show my screen quick because I can show. Hang on, let me get to the right. There we go. Cool. Okay, so in the example that I showed for the bounding boxes here, in the results array, I'm grabbing the box, which is from, so once I got my results from my session, let me make this a little bit bigger. I got my results. I'm creating an array of my boxes, which is I have a box class that we then loop through. And here, each index is then created. I'm creating that box from the prediction with the label and the confidence, and I'm adding that to a prediction array. And then I'm returning this prediction array to be drawn. So, and if I look at the box object here, this is what it is. So I hope that's kind of helpful. So like in this particular example, that is how we're grabbing it. So it looks like there's 4 coordinates coming back in this one. But does that maybe differ from different inferencing APIs? Like this is the C# one. And I think that maybe that could be maybe different implementations. But and then this also has like it's only looking at things with a certain high enough confidence score, because it might find things in the image that aren't really there and it'll be a really low confidence score. And it's like, I don't really want to draw boxes for anything below that. So for the example that I showed you, that is how that is working. And then somebody asked about the Skia-Sharp pre-processing, and that is, or they're asking how we were doing the image processing, and that was with Skia-Sharp, and that's how we're pre-processing those images and turning them into a tensor in order to send them to training. So yeah, hopefully that's helpful. Back to Calendly. Cool. All right. Is there anything else that you think would be useful, or any like advice for new people, or maybe like kind of any stories about how you got, how you got started with this, or anything else you want to share?
Yeah, I guess like the AI engineering space is just like it's a very complex space where it's an intersection of, math, machine learning, data scientists, all that, like the other half. And then it also involves some very hardcore engineering, like C++ programming. And then there's also like a lot of like ML ops kind of problems, like you need to be familiar with the Docker, the cluster, the AML, the whole like operational kind of thing. So this is the intersection point where the problem space is vast. So that's why this is so fascinating about this field of AI framework, and why Onyx Runtime is so cool. Like if you really think about its complexity, it's just mind-blowing. Yeah. So for anyone who is interested in this field and hoping to contribute, my only suggestion is pick your own favorite topic and start small. It's always good to start with a niche area and start from there and then grow. And you will run into bigger problems, and that's the fun and process of it.
That is fantastic advice. Thank you so much for sharing that. Like, we have a principal software engineer working on the project here, giving us this brilliant advice on how to do this. And I love the start small thing too, because everything can seem very big and overwhelming when you first start, if you look at the big picture. But when you start small and you do little steps, I always find like, a month later, you'll look back and you realize how much you learned and how much you're able to accomplish, and you'll probably surprise yourself. So it's always more fun when it's challenging. At least I think. Then I always get a little bit more excitement when it's something that I thought I couldn't do originally, and then at the end I was able to. It's like it's something that gives warm and fuzzies, makes you happy. So thank you so much, Sherlock. I really appreciate you taking the time to walk us through this and hanging out with us today. And I think now we'll bring Chengming in, and he is going to give us some resources and ideas about how to get started, where the issues are and all those where the GitHub issues are. Not where our issues are, we want to talk about those, but where the GitHub issues are and how to get started with those things.
Hi, Cassie, could you help me present the...
Yes, let me, wrong screen, sorry. Let's go back to, here we are. My bad, I forgot I was supposed to have this up.
That's fine. Hi, this is Changming. In the next, I will show you some cool ideas. The first one is machine learning-based perf tuning. So Onyx Runtime has tons of tunable compile time constants. They live in our source code as fixed values. That, for example, the block size used for doing general matrix multiplication. When we do matrix multiplication, we need to divide the original matrix into some smaller pieces so that each piece can be well fit into your CPU cache. But we don't know how large your CPU cache is. So we just choose a fixed value, 128 for everyone. But your CPU may have a larger cache, and it may benefit from a larger block size. So the idea here is we may tune the values based on perf benchmarks. We run some benchmark on your device, get the numbers, and use these numbers to, tune the constant, get better performance. Next.
Yes.
So here is an example how block size impacts the performance. In this graph, the horizontal line is matrix size. We assume all the matrices are square, and the number here is the number of elements in each dimension. The vertical line is G-flops, floating point operations per second in billions. Higher is better. The blue line here is our current setting. Block size equals 128. As you can see, if we increase the block size, it will be faster for some cases, especially when the matrix gets large. However, okay, that's fine. However, this data is just for one single thread, and we assume that only one CPU core will be used, and even this CPU has 4 cores and it has 8 megabytes CPU cache, which should be shared by all 4 cores. And we supposedly we assume all the other CPU cores are idle, but it's not real. And if you run the same code in a multiple thread setting, you will need to decrease the CPU cache based on your usage. Next. So question is, can we calculate it dynamically? Can we develop a formula to find the best CPU cache? Well, back to 1980s, it's possible that if your CPU hierarchy only has 2 levels, fast and slow. Fast means the CPU cache, slow means the main memory. We will assume that your CPU only have 1 level of cache, and if you only have 1 CPU, 1 core, you may be able to, get a formula like this. But the real case is far more complicated. And modern CPUs works like a black box. It has too much details inside of it. Intel won't tell us what's their CPU cache algorithm. That's their high-level business secret. So I think we couldn't find a very good formula to predict the performance accurately. But still, any improvement is welcome. If you think you can find one, and please try it. create a pull request, and will help you do some benchmarks. And it's a chance for you to develop put your code on billions of devices. Next. So, well, instead of having a formula, here's another idea. Like we let the computer generate a large set of possible color variants and search them for the fastest one based on benchmark results. This is an old idea from Atlas. It has been proven works very well. But what's new here is we may use machine learning to guide the search. Instead of searching every possibilities, we may put some assumptions on the function that we are optimizing. For example, we may assume the function is smooth or continuous or convex. And in that case, instead of try every possibilities, we may jump between the values and find the best one faster. And I got the idea from the following paper, and they also open source their implementation. So we may try to, integrate their code, integrate their tool to action time to try to see if it can help us get better performance on some hardwares. Next.
Cool. So just a quick kind of question here. So this is something that you think would be able to improve Onyx runtime based on this paper, kind of come in and integrate that into the existence to improve like the performance type. Is that right?
Yes, yeah. Okay. For example, someone is interested to produce a special build for Raspberry Pi. And we may firstly run some benchmark on their device, get some number, and change our code for that device. Here, when I said code variations, it doesn't limit to block size. It also refers to maybe some different algorithms for doing matrix multiplication. And you may have your ideas, your new algorithm. You may help us, implement into our code and make it run faster.
Cool. This would definitely be more probably on like the advanced side of a contribution, right?
Yeah.
Okay. Oops, I went too far. Okay. Sorry. Right.
So how to get started? Action Time is a GitHub project. It's hosted on GitHub. So it's like the other GitHub projects. You can follow the typical process. So, first, you need to create your GitHub account. You need to have an account. Then you fork our code into your account, create a branch, create a pull request, and then we will review your pull request and run the perf benchmarks and unit tests. Then when the review is done, we will merge your pull request, and later on we will put it into our release, and you will get the chance to deploy your code on billions of devices. It's a really very good chance. Next.
Quick question on that. So for the running the unit tests part, so like when you submit a PR, do those unit tests run automatically, right? And then once those are all passing, that's when a reviewer would look at it, right? Or do they have to do anything manual to get their unit tests run?
I'm sorry, we need to do it manually. I mean, the developers in Action Time team need to manually schedule or run the tests for you.
Okay, so the Onyx runtime team runs the test.
Yeah.
Okay. So you submit your PR, and then from there, when it gets reviewed, they would run the tests, and then it would get merged if it was approved. Correct?
Yeah. Yes.
Okay. Cool. I just didn't know. Is there any way for them so they can't run the test like locally or anything like that? Like they can't do any tests on the run before that happens, or can they?
You can run most of the unit tests locally when you build the code. Yeah. By default, it will run most of the unit tests locally, but we also have a larger set of model tests, and you don't have the models, so you need to ask us to run tests.
So you can run some of the tests on your own locally before you submit your PR, and then once it's there, then it's kind of just waiting for the team to kind of take a look at it and do the additional tests, probably performance tests with different models for different benchmarks, and then review it and approve it.
Yeah.
Okay, cool. Thank you.
Next. Next, so how to pick up a topic? So instead of the previous one, we have many other things to do. For example, we have a long list of GitHub issues. Many of them are marked as contribution welcomed, which means currently we don't have an engineer to work on that. So you may pick up the things you are interested, or you may have us write some examples. For example, we have a fast RCN example in Python. If you are familiar with both Python and C++, you can help us port it from Python to C++. And also you may follow our tutorials. And whenever you encounter any issue, you may please note it down. And then when you get it over, please help us update the documents, make it easier for the other people. Or please help us implement the new Onyx operators. Onyx will publish a new release every few months. And at that time, they will also add a lot of new Onyx operators into the new release. And we need engineers to implement them. And this is a major part of our daily work. So please join us, help us improve it. Thank you. That's all from me.
Quick, can I ask you a question on the Onyx operators? What level of skill do you think does it take to implement a new operator? Would that be something that would be beginner friendly because they can kind of look at the way other operators were implemented, or is that still something that maybe needs a little bit more of like the intermediate level of skill?
First, you can try to look some examples of some very simple operators, get familiar with the interface. For example, the tensor shape, the common classes we are using, and the domain that you are familiar with. For example, we need someone to implement the FFT, and if you know what FFT is, which means faster Fourier transformation. Yeah, transformation. If you know the algorithm, then you can help us implement it. Or you may try something different that which is comfortable for you.
Cool. That's awesome. I think that would be kind of like a cool place to start if you're comfortable with the like space a little bit, implementing a new operator.
Yeah.
And then like also the docs and the issues, I think those are like kind of the best like beginner ones, is finding one that's interesting to you. And then I think the original example that you kind of went into before we jumped into this too, I think that's probably more like the advanced. So like no matter wherever your skill level is at, there's like a lot of different places you can start based on your comfort level.
Yeah, for example, if you are familiar with image processing, you may help us to implement the image resize. For example, how downsampling an image. Onyx has a great connection of different operators, and our engineers cannot be familiar with every algorithm. It's not possible. That's why we hope more and more developers can join us.
Awesome. I love it. Yes, please do. And then we also, so I have some resource slides here. Did I get that? Okay, cool. So I know there was a lot of links that were shared, and I apologize, I did not get them all on here, but most of it's in our GitHub or on our docs. So like, as long as you get to our GitHub or our docs, you're going to find what you need. So within that, we have just like, so this is where our GitHub is. It's, GitHub/Microsoft/Onyx runtime. Be sure to tell us about what you're working on with Onyx runtime. Like, we'd really love to hear questions. So you feel free to tag us, or the other thing we have is a discussion. So that's the other thing when you're thinking about ideas, you could jump into this discussion because there's things in there that are feature requests. There's things that people have had problems with and they have questions. Or if you have questions while you're building, you can jump into the GitHub discussion, which is just Microsoft/Onyx runtime/discussion. And then the wiki that you saw is just /wiki. And so once you get into our GitHub, you should find everything you need. And then or t.ai will bring you to onyxruntime.ai as well. So those are some resources to get you started. And I just want to thank both of you so much for taking the time to do this. And I found it super useful. I hope you all did. And I hope that you'll think about participating in Hacktoberfest and kind of going further in your machine learning journey. So thank you so much.
Awesome. Oh, Cassie, you are, there you are. There's your face. Here's Sherlock. Wow, this was cool. Way to take over, huh? You got like some elevator. The captain has taken over.
Yeah. You listen when the captain is in, like you pay attention, right?
Yeah, if you could send me, can you? I don't know if you can drop a link.
I always wanted to do that. Okay.
Oh, wow, you are the captain. Well, I'm gonna say goodbye to you, Changming, and then Sherlock. We'll see you later. Cassie, you're the best. This is awesome.
Thank you so much.
I've always wondered how it like actually worked underneath.
Me too. Right?
Have you done anything in the code? I'm too afraid to download C code.
I have only worked in, like, the only thing I've contributed was to the C# Onyx runtime package, and where there was a property that I needed access to that was a private value. So it wasn't anything super complicated, but what I learned was a lot even though I did something that like really was not that complicated in the schema of like everything you can do with Onyx runtime, just downloading the code, getting it running. I built, a custom environment in Conda to have my custom package running to then go test it. And it was just like a really good learning experience. And so I think like they said, the kind of that like first step where you could just get into the different inference session for the different libraries. Like, they have JavaScript and C++ and Java and C#. I really do think that's a kind of a good way to get started and make sure that you can access the different like properties that you need, or even just getting comfortable, creating Conda packages and working in open source. So there's like the thing I love about this project is there are like so many levels you can do. Like there's very, very beginner, and there's super advanced like research stuff. Like it really is wherever you want to start. And so that part I think is pretty awesome.
So just to be clear, you're asking folks in October, how far into October are we in?
We're halfway through.
Halfway through.
Yeah.
So there's still 2 weeks for you to contribute stuff, and like, other than learning and the sense of satisfaction that one has in contributing to an awesome project, what do they get? High fives from us? Will we send them a nice note?
So I think I have to double check the Hacktoberfest site, but I think it's something like there's a ton of different projects that are included, but I think if you submit, like if it's 4 or more PRs throughout Hacktoberfest, I think they send you like swag. Like I think Hacktoberfest does. Yeah, this year we didn't plan any prizes, but I think next year I'm hoping that we'll be able to, because so but anyway, so this year there isn't anything directly from us, but there is stuff I believe from the Hacktoberfest, and then also you can look at all the different, like there's so many different projects that are going on, and so I think it's just a really cool way to kind of get started in open source. Like myself, when I first started out, I was always like really nervous about open source, because I was like, oh no, they're gonna like judge my code and all of that. But they have really good, open source projects have really good documentation on like what they're expecting and what they want, and kind of like processes and things like that. So I think this is a really cool way to kind of push through if this is your first time contributing some of that like beginner anxiety, because there's so many different people that are starting out in open source contributions this month.
Yeah, all I know is the last time I had to write C was in my operating systems class, and I had some leaks.
Yeah, and then but there's the JavaScript library.
That's true, and that's the one that I've been using a lot, actually. If I'm thinking about it. Okay, cool. Well, I put the link up. Microsoft developer was kind enough to put the link. Hacktoberfest.
Awesome.
Is that it? DigitalOcean.com?
That's it. Yep. And they've been, I think this is the 8th or 9th year. I'm not exactly sure, but it's been going on. The Hacktoberfest event has been going on for a while. It's very community driven. It's pretty cool.
I love it. All right. Well, my friend, anything else you want to add?
No. Thanks so much for having me in.
Sorry, I switched the music there. Got a little. All right, my friend. I think I'll try to contribute. This is, for those that may or may not know, we have a big conference coming up called Microsoft Ignite. It's November 2nd through the 5th. And this is the hair on fire time for some of us. So all this happiness that I have is likely going to dissipate. Going to get less happy over the. All right, Cassie, you're the best. We'll talk soon.
All right, thanks. Bye.
All righty, take care. Cassie's awesome. All right. I think we got, what, 15 minutes to get to work. So let's do that. Here we go. code. Here it is. I'm trying to remember what we did. I don't remember. I did learn how to do something new, though, for those that are wondering. Let me open up a web page here. Look at this beautiful picture. GitHub.com. I found myself in need of having to write static web apps a lot, and I found that if I have a base project, that then I can there's a way here. Let me do this right now so you can see. This is public. I'm gonna make this a template repository. So basically, whenever I start a new one, it has everything in there that I like, like the app and the API, and then you can do the SWA. Because remember, I keep on having to type stuff in, and I figured out that if I do this, I can just do SWA start dev, and things will just work instead of me having to type stuff all the time. The other thing is I don't know if I like the workspace thing, if I'm being completely honest. I don't like it. It just doesn't add anything for me. And so I'm going to stop using the workspace. So I'm going to say open folder, and we're just going to select this folder. And that's it. Now we're back to our, I don't need this. I'm just going to delete this. Delete. And what I'm going to do is, I think I can close this. I don't need this. Close this. Goodbye. And what I'm going to do is I'm going to add this CLI thing that I just found. That way, when I start it up, it's soups easy to start it up. So it looks like this is the name of the file. So we'll create a file like that, and then I'll run it and show you what we've been doing. Oh, goodness. Things are slowing down. Oh, no. Here, so we'll do this, and then I'll take, because I figured this out the other day. Boom. And then I'll just put this in here. Except this time I think it's web. CD web. And yarn dev. That will start it up. And now, basically, I think I just hit F5 to get the back end going, which is the API. Let's see if that's right. By the way, y'all are awesome. Rochambeau rocks indeed. Bicap, yeah, she's fantastic. There you go. All right, I'll reload you later. Okay, so here's the back end running. This is the API. Uh-oh. What? Well, I'll have to figure this out, huh? And then here, what I'll do is hold your horse. I'll do it. Here we go. And I gotta watch the time because we don't got as much time as I would like. Here we go. It's running. This thing is running. Cool. Terminal. And then here, I think I can just say, let me go back over here to remind myself. Baster. SWA start dev. SWA start dev. Beep. Let's see if this works. And now basically I've got the back end and the front end running together with hot reload on the React stuff and breakpoints on the other stuff. So let's go over here to the API. And I think this is a post image. And this is the thing, right? I'm not gonna set it. Maybe I will. I'm just gonna. And then I'm gonna take this beauty, boop, Control C. Yeah, and load it up. Just to remind you of what this thing actually does. So, oh, that's gonna break it. Oops. I think that. Oh, jeez. Everything is so slow today. No slowness. Oh, thank you. I guess I got a new version of Edge. Thank you. Okay, let's close this. Here we go. Things are loading up. I can't select the camera. Everything is broken. Your connection isn't secure. Permissions for this site. Here we go. I can use the camera. Allow. Wonderful. Now let's refresh. Boop. Refresh. Alrighty, and now, HP Pro Webcam. Boom! There's 2 sets. Oh, one is freezing. Oh, And then when I hit submit, what the heck just happened? Things are just all over the place here. Sony, no, not that. This one. This one. Okay, here we go. Submit. It's supposed to give me, what is this? It's the image, but it's not giving me the return. Did I not check stuff in? What's going on? Oh, it's because it's stopping on the breakpoint, and I'm, there we go. It stopped on the breakpoint. That's what's happening. Let's go back over here. And there you go. Prediction says rock, but it's clearly not right. Okay. Let's see what happens when I go like this. Let's do a paper. Let's do paper. I gotta move my mic here. Paper. Why is it rebuilding? What is going on? Why are you doing that? What are you doing? Stop it. This is still going. Okay. All right, here we go. Okay. So, we'll pick the this thing right here. Paper. It's hitting the break. Stop hitting the break point. Okay. So there's the break point. Oh no, it's just not doing the right thing. But that's okay, because what we've done is we've basically taken this image and squished it so that it would fit. Kind of cheating. All right, what did Jay say? Something funny? You can ignore that NPM moderate audit. Oh, yeah, that's true. Why does this keep restarting? Stop it. What's going on? Does it just refresh? Here, let me stop this. Stop it. Stop the back end here. Here, we'll do this. I don't know why it keeps doing that. That's a little concerning. So now what we have to do is we have to figure out a way to, when we convert this picture that comes in, to resize it. So, Avi, because we're professionals, how to resize an image with Node. Okay, here we go. Best interview question. Node.js is a server. What is this? Wait. Oh no, I thought it was like Node.js is a server-side open source cross-platform JavaScript runtime environment used for. Okay, let's get to the thing. Install Sharp module Node.js. Okay, I could have just said that. Module Node.js. What we got? Here we go. The typical use case for this high-speed Node.js module is to convert large images in common formats to smaller web-friendly JPEG, blah, blah, blah. Resizing an image is typically 4x5 using quickest image magic and graphics magic settings. So I wonder, should we do this on the client side? Huh. Interesting. Let's go to the repo here and see what we got. Install, require, input buffer. What is the input buffer type? Input.jpg. Looks like it's a file. Stream. Buffer from. Oh, interesting. Let's take a look at the issues. 106. Can we skip process? Good grief. I don't know. I don't know if I like this. I don't know if I like this. Let's go back to something else. How to resize an image in Node, kinda code. Easy. Oh, Stack Overflow. They'll have multiple answers. Pack Image Magic, Image Resizer, Easy Image. Use Image Magic. What's Image Magic? The problem is, for me, is that I am passing, okay. This is an abandoned version. Okay. All right. There you go. The people's developer. It's like The Rock, but for developers. He's the people's developer. You can install blah, console, convert.path. Interesting. I wonder if it'd just be easier just to clip. All right, how to pass? Oh, maybe. There is a way to pass an image via instead of. What am I passing? I don't even know what I'm passing. I gotta remember what I'm passing. I think so. Let's do a little breakpoint here. I think I have to start this again. Okay, it started. Let's go to this thing over here. I'm trying to remember what it is that I'm passing, because maybe I can pass. Here we go. I'm passing. Oh man, I'm passing like a whole array. Oof. I wonder if it would be better to pass and okay. There is a way to let's see here. Inline image data HTML. There's a way to inline image. Oh, there it is. Base 64 encode an image. I wonder if this works with a base 64 encoded image that then I can pull the bits out of. Oh, crud. Oh, my goodness. It's time for the walk-off music. My goodness. That has gone by quite fast, my friends. But it looks like I need to be a little cleverer about this. And then I think my model just stinks. Maybe I need to use a better model. F5. Well, my friends, our time is almost up. It has been an absolute joy being with you, my friends. As always, next week, Aishigal is back with Translator now supports 100 plus languages and dialects with Christian Das, Mohammed, and Diego are going to be on our show next week. It's been a privilege being with you. Thank you for letting Cassie hijack. She is fantastic. That was just amazing. I had a really good time with that as well. And earlier today, we saw Swati with AutoML for images. We got a little started on our project. I made some convenience changes. I don't like the workspace if it's all in one folder, it just doesn't make sense for me. So thank you so much for being with us, my friends, and hopefully we'll see you next week. This has been another episode of the AI Show. Take care.